Hello.
Hello everyone. So in front of you, you see a blank screen. And what we're going to do, we're going to flash some images on the screen, and I want you to yell out what they are as soon as you recognize them. You ready?
Banana. Yes. Apple. Yes.
Mop.
Yeah. Dog.
Dog.
Yes. Mop dog,
Mop
perhaps?
dog? Yeah.
All right, it's kind of awesome that our brains and as humans were able to recognize these images within seconds. But the question is, how do computers do it? So this is a zoo.
And this is Natalie. And we're students at the University of Connecticut. And today we're going to be talking about image recognition through machine learning.
Yes, let's get into it.
All right, so first we're going to talk about the basics of machine learning and how that's applied in image recognition and how we can apply that in the future.
All right, so how does machine learning work? Let's get into it. Imagine that a baby human is a computer. And as the baby is learning how to walk, it's going to fall a lot. But with each step, it's going to learn something new until eventually it walks properly and efficiently.
Yep, and then with enough practice and data and through machine learning, the computer is going to be able to do a certain task or solve a certain problem. Now, the engineer's job in this is kind of like the parent to the computer. And what he or she is going to do is kind of help guide the computer through what's called supervised learning. And in doing so, it's going to tell the computer what outputs it wants for certain inputs, and after many, many trials and iterations of that, the computer is going to be able to perform that task or solve that problem with accuracy comparable to humans.
And it's quite exciting. So let's see, how does it work exactly? So the question posed is, how is machine learning used in image recognition? All right, so let's say you, the audience, you are the computer, and we're going to give you two definitions. The first definition is if something is yellow, you're going to recognize it as a banana.
All right, and if something is round, you're going to recognize it as an apple.
Right. So if an image is presented to you, let's put this to the test, and it is yellow, you will recognize it as a banana, right? And if you're presented with something that is round, you would recognize it as
an
apple, right? But what if with these two definitions, now you are seeing a different image that is quite difficult to understand as a computer, and it is a yellow apple?
So in this situation, what the computer engineer has to do is go back and do that supervised learning. It has to go in and tell the computer that this is in fact an apple, and from there the computer will put more importance on the shape of the fruit than the color in determining which one is which.
Right. So let's see, how does it work exactly? Let's break it down to even smaller pieces. And these very small pieces are called pixels.
Yep. And so here we broke down the image of the apple into pixels. And we're going to slice that picture up. So here we have it sliced horizontally and lettered from A to L. And we have it sliced vertically and numbered from 1 to 11.
Right.
And it's a lot like a game of Battleship.
Exactly.
So what the computer's going to do is go through each of these pixels and determine whether there's apple inside of that or not. So let's start here with E1. Sorry.
Right.
Is there an apple in that box?
No, right? There's not.
Right. And let's go to the next one.
So is there an apple in E2? Yes.
Yes. And the computer's going to go through and fill in zeros for if there isn't an apple and ones for if there is.
Right. And this is very important in computer science and engineering because 0 means no in binary and 1 means yes in binary. We filled the whole board with zeros and ones. And the point of doing this is that when you take away the image from the background, the computer and ourselves are still able to recognize that it is something round and therefore is an apple.
Exactly. And the computer picks up on the pattern of this coordinate system and where each of these ones are so that it will be able to recognize it as an apple in the future.
Yep.
All right, so now that we've talked about image recognition and how that works, let's see how it can be applied. So one way is in cars. Currently the technology used in cars is more sensors than camera and image recognition. And what these sensors can do is determine whether there's an object there. So for example, a sign or a person. But they can't really tell the difference between the two. So in the future, where the decision between the two may be important, the use of this quick image recognition through machine learning will be important and could potentially save someone's life.
Right. And another real future application is in medicine. So for example, as a computer science engineer, you would be recognizing this brain scan, pixelizing it, enlarging the image, and comparing it to healthy brains. And the purpose of this is to save someone's life. So you future engineers sitting right there, listen up, because you can be among the greats. There are so many problems that are unsolved today, and we really need you to do them and to solve them and to work on them if you'd like.
Right, so right here on the right, that's Margaret Hamilton standing next to her code that was used for the Apollo missions.
Yes. Do you see this amazing stack of code? You can also be like Clarence Ellis here at the top. What he did was he developed the idea that you can double click on an icon. It was something so small, he had a huge impact. And you can have the same impact.